Okay, today we're going to talk about Lewis dot structures, Lewis structural formulas. First, we need to recall how to do a Lewis dot structure for a single element. So we're going to do sulfur. We know sulfur is the 16th element on the periodic table. So we're going to do the electron configuration: 1s2, 2s2, 2p6, 3s2, 3p4. So then thinking about the highest energy level that we see, we have third energy level, because this is a 1, this is a 2, so they're lower. So we look at the highest energy level. We got 2 from there, we got 4 from there, so we have a total of 6 valence electrons we need to put in our structure. So we're going to draw sulfur, and we're going to start on the left, right, top, or bottom. I always start to the right, and I go counterclockwise, doesn't matter, but you do 1 dot per side, and then you double up. So 1, 2, 3, 4, 5, and 6. So we have 2 pairs and 2 lone electrons for a total of 6. And another way you could do that is you could have looked at a periodic table. A quicker way of doing this is to look at a periodic table. And here you see a periodic table, and you can see sulfur is right here, and it is in family, it's in the 6th family. We're looking at that 6A, not the 16, the 6A, so it has 6 valence electrons. So I could have gotten my valence electrons to be 6 just based on the fact that it's in the 6th family. All right, so let's continue on to the next slide. Here I'm demonstrating to you what would happen when we connect 2 dots between 2 atoms. We haven't done that yet. We've only dealt with single atoms. So here we have 2 dots between 2 atoms, and we call that covalent bonding or sharing of electrons. Here in this case, so we have 2 dots and they become a single stick. So every single stick is a pair of dots. So we call that a single bond because there's 2 dots making a single stick. Double bonds are going to be when there's 4 electrons between 2 atoms, and we call that a double bond. And each of these 2 electrons, each of those electrons become a stick, and we count those as 2, or a single bond here and a double bond there because there's 2. Here we have 6 electrons between 2 atoms, forming a triple bond. Again, 6 electrons, 2 of each 2 electrons pair up, become a stick, so single, double, triple bond. Okay, so these are the steps that you will follow. These are just one method, the method that I like to teach. There's another method on your sheet. This first method is not the one I will show you. I will show you this one because that first method is a little more difficult. So I'm going to go through these steps, but I have written these steps in a more shorthand form. I'll explain what all of these items mean as we go through our first example. Okay, so let me expand my screen a bit. So here we have our first example. We are on, currently this year it's on page 3 of your packet. I'm not sure what page it'll be on, but you should be able to find this. The title of this page says Lewis Structures / Structural Formulas. Okay, so we are going to begin by calculating our magic number. So what you're going to do is you're going to look up each element in the formula and figure out so we're going to list the elements. Okay, we're looking for this magic number, step 1 right there. 1 nitrogen, 3 fluorines. And then we're going to figure out how many valence electrons they have. So we're going to go back to that periodic table. Nitrogen has 5 because it's in family 5A, and fluorine is in family 7A. So looking at the top of the column or the group 7A. So nitrogen has 5 and every fluorine has 7. So we're going to say nitrogen is 1 times 5 because there's 1 nitrogen in a formula, 3 times 7 because there's 3 fluorines in the formula. So you're going to multiply the number of each atom you have times its valence electron. So this is a 5 and this is a 21. So we get a 26 here. That's our magic number. So then we've done this step. Now we're going to do single sticks, meaning we're going to connect the elements together. Whatever is first is central, but hydrogen is never central. So this element is central because it's first, or you will have an element underlined. So if it's underlined, that's central. Otherwise, whatever's first, unless it's hydrogen, is central. So we're going to put nitrogen in the center. We're going to attach with a single stick, or what we call a single bond, the other elements in the formula. We have 1 nitrogen and 3 fluorines, so I'm going to attach 3 fluorines to nitrogen. Why is nitrogen in the central, or is everything attached to nitrogen? Because it is written first. So we've done the second step. Now we're going to give everybody octet. Octet means everybody gets 8 electrons around it. So 4 pairs or 8 electrons around it, except for these 3. Hydrogen, boron, and beryllium will not get 8. They basically get however they land when you put them together with other things. So I'm going to start with this fluorine. Okay, we've got, remember this counts as 2. That's a single stick. So 2, 3, 4, 5, 6, 7, 8. And what we're looking at is electrons around an element. So a stick counts as 2. Every stick counts as 2. So this one is 2, 3, 4, 5, 6, 7, 8. This stick or single bond is 2, 3, 4, 5, 6, 7, 8. So now all of my fluorines, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, have 8 electrons. Now, we cannot neglect the central atom. That's the nitrogen. It is not one of these 3, so it gets octet also. So right now, nitrogen, as it's written, has 2, 4, 6 electrons, so I need to put 2 dots on the top of this to give it 8. We'll always put electrons in pairs. And so now we've obtained octet. It's so important that you make sure everybody has octet before you see if you've got the magic number obtained. So magic number obtained means now that everybody has octet that gets octet, again, these 3 are the only 3 that don't, and anything that I would give you. So you are going to now see if you can get to 26 electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. That is a check, and that structure is done.